Welcome back to the channel. If we take a look at the direction in which databases are evolving, driven by the twin factors of the cloud and big data, let's start with a quick look at the cloud computing and explain the big data explosion, focusing on its impact on the database systems. We will trace the evolution of databases from a simple flat file to enterprise RDBMS and NoSQL databases. Briefly touch on the NoSQL movement, a cap theorem, and acid versus base semantics. The second part will uncover the challenges of next generation databases, and we see how the database research aims to address these needs using emerging technologies like non-volatile memory and the many core revolution in this sector. What are the two mega trends in the computing history? What are the two mega trends in the computing industry likely to be in the coming decade? Most IT industry folks would name big data or cloud computing as the driving forces shaping the industry today. The computing world is shifting from the enterprise-centric to data-centric workload driven by the big data revolution. While cloud computing is becoming a mainstream, reinventing the utility, elastic computing as the new mantra for the IT industry. The influence of these two paradigms is driven the revolution in different fields of the computing industry, such as processor platform architectures, programming models, programming languages, and software stacks. To name just a few, after all, no one would have a paid promotion to map reduce as a programming paradigm. It was not the Web 2.0 and the shift towards the cloud computing. The field of database is no exception. It has been influenced heavily by these two driving forces. The cloud computing is driving the momentum towards making the database available as a service on the cloud. The big data is changing the traditional way in which data is stored, accessed, and manipulated. With the arrival of the NoSQL movement and the domain-specific databases, resulting in moving computing closer to the data. And if you ask the internet, the savvy, the cheeky question, what is the connection between Cassandra, Voldemort, and Dynamo? Obviously, it's not related to some interesting stories. You can expect the majority to give you the correct answer that they all are specialized NoSQL databases. The fact that the database are no longer the domain of a few specialized expert programmers that signifies the shift of the database movement from an enterprise-centric workload to focusing and delivering on the needs of the social media network, collaborative computing, massively multiplayer online gaming. The cloud computing is transforming the way data is stored, retrieved, and served. Computing resources like servers, storage, network, and applications, including the databases, are hosted and made available as cloud services. For a price, cloud platforms have evolved to offer many IT needs as online services without having to invest in expensive data centers and the worry about the hassle of managing them. Cloud platform virtually alleviate the need of having your own expensive data centers. Today, most of the managing cloud platform offer to design, develop, test, deploy, and host the apps in the cloud environment with impressively economical cost models. Amazon EC2, Google Apps Engine, Microsoft Azure, Apache Cloud IQ, AppScale, AT&T Synaptic, and Rackspace, just a few of the offerings. What are the various classes of cloud computing? Such as SAS, which is simply termed software as a service, which is the delivery model wherein business application software is hosted on the internet or cloud centrally and can serve the multiple customers on demand. The platform as a service provides all system and environments encompassing the software development lifecycle, including the development, testing, deploying, and the hosting of the business applications. It includes Google Apps Engine and Microsoft Azure. Infrastructure in terms of computing resources and operating systems is also offered as a service. After all, the hosting of business application on the cloud also entails the maintaining and manipulating the data by the application. Initially, it was left to developer to install, manage, and use their choice of database instances on the cloud. With the burden of all the database administration tasks being left to the developer, the advantage of it is that you can choose your own database and have a full control over how the data is managed. In order to simplify the burden for the users of their cloud offerings, many platform as a service vendors today have started offering database services on the cloud. All physical database administration tasks such as backup, recovery, managing the logs are managed by the cloud provider. The responsibility for logical administration of the database, including table tuning and query optimization, rests on the developer. The choice of database is also limited typically to MySQL or Oracle RDBMS. For example, Amazon Relational Database Service, Microsoft SQL Azure, Salesforce.com offers database.com, which is actually built over the Oracle's real application clusters. Through database.com itself does not support the traditional SQL. The query language it offers is built upon the SQL. It is known as Salesforce Object Query Languages, which limited querying capabilities. It is internally translated to SQL by its system. While these are the cloud offerings of database services, the underlying technology is still traditional SQL-based database technology, not specifically reinvented for the cloud. It also has been considerable buzz around the offering to let database as a service, wherein an organization's database needs are met by the database offerings on the cloud. The two use case scenario of database as a service portfolio as a single large organization that has many individual databases which can be migrated to a private cloud for the organization, and outsourcing the data management needs of small and medium organization to a public cloud provider which caters to multiple small and medium businesses. A true DaaS offering should satisfy the certain requirement, such as freeing the end developer, database administration, tuning and maintenance the activities, offering the high performance, availability, and the fault tolerance, as well as advanced features like snapshot, analytics, and time travel. Elasticity on the ability to dynamically adjust to the changing workload. Elasticity is required to meet the user service level agreement while minimizing the cloud provider infrastructure, power, and administration expenses. And the final, security and privacy guarantees pay as per your uses pricing model. As per your uses pricing model, today there are not any true database as a service offering that satisfy all requirement. Therefore, these cloud computing needs will drive the next generation of database evolution. That's all for now. See you in the next video. Thanks for watching.